Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdullah Hamiduddin, and today we will discuss an EE471 project topic of prosthetic devices, in particular bionic arms. Improving quality of life is an important objective of medicine and biomedical engineering as a whole. One of the methods to do so is through the development of prosthetic devices to rebuild some lost physical function of the body. And in this example, it is to achieve upper limb function such as arm and grabbing as it's shown. To learn more about prosthetic devices, we'll go through a general introduction regarding prosthetic devices, and then we'll go to the theory for bionic arms and its instrumentation, and then lastly we'll go through some technical specifications for bionic arms. By definition, a prosthetic device is generally any artificial device that helps replace, correct, or support a body part or function. To put it simply, it replaces a part of the body to correct a physical deformity or physiological malfunction of some sorts. Such devices can be implanted or externally attached. Some of the examples of prosthetic devices are shown here, including a prosthetic hip, a pacemaker, and prosthetic heart valves. The theory behind such devices cannot be properly explained as each category of devices has its own theory. To further explain the theory behind such devices, a specific group of prosthetic called bionic arms is explained. Bionic arms are simply prosthetic arms that can be controlled using different methods such as neural sensors, brain waves, or myoelectricity. The main theory behind bionic arms is that they use different biological signals such as neurological and electrical signals to detect a change that corresponds to an action initiative, such as clenching a fist or extending an arm. The signal is carefully processed to interpret the duration and strength of the action. The signal is then relayed to a control unit to interpret such action. Then it is converted to an electrical signal that controls a motor to perform mechanical operations in the arm, such as moving the fingers or extending the arm. Some state-of-the-art bionic arms might include AI or advanced algorithms to further advance the process, allowing for wider range of actions and selectivity. In regards to a basic bionic arm system, it usually includes the following systems, including signal acquisition, which may include sensors, transducers, or implants, where the main purpose of such system is to acquire the selected signal, whether it be an EMG or an EEG signal. Then it is moved to the signal conditioning, where different operations are performed on the signal to prepare it for the computer interface. Such operations include amplification, filtering, and analog to digital conversion. Then we move to the control system, which is usually comprised of microcontrollers, a computer interface, processors, and any related software to convert such signals into an electrical pulses, which is then transferred to the movement system, which includes any motors or servos to perform the motion, any gear or moving components such as cable, joints, or stepper motors. Lastly, it's the feedback system, which is an important system that controls the system optimally. This might include feedback to the arm, such as detecting maximum grip, vibration, or feedback to the brain via electrical pulses to indicate the end of a movement. A shown example here, including a basic system, such as the implants here, where it's considered part of the signal acquisition, a transmitter and telemetry controller, which is part of the signal conditioning and control system, and then the prosthetic hands, which include the movement system. Moving on, the technical specifications for bionic arms and prosthetics in general are based on the different application and type of device. Some of the general technical specifications for bionic arms are shown on the figure on the left, which include the degrees of freedom, the number of actuators, mass, grasp patterns, and grasp speed. For the different classifications of prosthetic limbs, a basic categorizing system is usually used, which is as the following, where we mention the level of amputation and its location, such as the upper limbs, including transradial, which is below the elbow, and transhumeral, which is above the elbow. In conclusion, prosthetic devices are a vast field that cannot be simply explained in a short presentation, as each type of prosthetics has its own technology and research areas. For this presentation, we discussed the theory of bionic arms and its instrumentations, and lastly, the different technical specifications regarding bionic arms. At the end, I hope this presentation was insightful and enjoyable for you. Thank you for your time.